Okay, here's question 4C from your homework on lesson 7, which was double angle identities. And 4C is probably one of the more complicated questions. So what the question says is use a double angle identity to simplify and evaluate. And it gives you the sine of 5 pi over 12 times the cos of 5 pi over 12. I wrote your double angle identity below here. So this is what I wrote from your formula sheet. And whenever you have sine of x and cos of x, that is going to be the double angle for sine of 2x. However, what we are missing is this 2 here. Right? So x is 5 pi over 12, right? This is 5 pi over 12, and this is 5 pi over 12. But what they are missing is the 2. So I need to put a 2 in front of that expression. Now, remember in math, you can't just add 2 out of nowhere, right? So in math, what you have to do is you'd have to balance it. And if I add a 2, right, and we can't just add 2, how do you balance that? In front of your expression, you would add a 1/2. And the reason why you would add a 1/2 is because 1/2 times the 2 that I just added equals 1, right? So if you multiply something by 1, you actually haven't changed it at all. But now that I've got that 2 in front of there, I could now rewrite this as my double angle. Right? So I need to keep that 1/2. I can't drop that 1/2. And in my bracket now, this is a double angle. And that double angle is the sine of 2 times 5 pi over 12. So 5 pi over 12. Okay? From here, that would be equal to 1/2 times the sine. 2 times 5 pi over 12 is the same thing as 5 pi over 6. Here I have your Cartesian plane or your unit circle at 5 pi over 6. What's your sine value? What's your y value? And that would be 1/2. So this is equal to 1/2. And then again, sine of 5 pi over 6 is 1/2. And when you multiply a half times a half, your final answer is 1/4. And you would be done.